All right, I'm back. I left off at page 251, number 13D, which asks us, is it possible that Josh can have 13 toonies and 5 loonies? So if I have my original equation, which is $32 equals 2x plus y, then I'm going to plug in 13 for toonies and 5 for loonies. So 2 times 13 plus 5, 32 equals 26 plus 5, 32 equals 31. No, it does not. So therefore that's not possible. And the reason for that is because toonies are always even, right? Because you have them in pairs of 2. So the loonies must be even as well because we have to get to $32. All right, number 14 says, John said to solve this equation, 4 equals negative 2x minus 3. I graphed y equals negative 2x minus 3 and y equals 4. The x value is where the two lines intersect is the solution. What is the solution to this equation based on the graph? So A, the solution was x equals negative 3.5. B, verify the solution using algebra. So if my equation is 4 equals negative 2x minus 3, I'm going to add 3 to both sides. Now I have 7 equals negative 2x. Divide both sides by negative 2. Negative 3.5 equals x. So yes, that's verified. C, why is it reasonable? Because the solution is the point of intersection. Because if they both equal y, so y equals 4 and y equals negative 2x minus 3, they both equal the same thing. So that means they can equal each other. So where they intersect is the solution. And D says, how could you use this strategy to solve 3x minus 4 equals 2x plus 3? So to solve that, I would graph y equals 3x plus 4, and I would graph y equals 2x plus 3, and then check to see where they intersect. All right, number 15. Solve each of the following systems of equations using a graph. So I have y equals 3x minus 1 and y equals negative x plus 5. So I need to graph both of these lines. So this is in y equals mx plus b form. So m is my slope and b is the y-intercept. So in these situations, m equals 3. It's the number attached to the x. And on this one, m equals negative 1. And b, the y-intercept, equals negative 1 on this one and equals 5 on this one. It's the number that's by itself. So in order to graph these now, I'm just going to get some graph paper. I'm going to draw these on the same axis. So I'm going to plot my y-intercept. So negative 1 and 5. 1, 2, 3, 4, 5. And then for my first one, where my y-intercept was negative 1 down here, my slope is 3. So it means I'm going to go up 3, 1, 2, 3, and over 1 and draw a point there. Up 3, 1, 2, 3, and over 1 and draw a point there. Then I'm going to connect that line best I can. So that's the first equation. The second one, so my y-intercept was 5, and then my slope is negative 1, so I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, and then connect that. Now I need to check where do they intersect, and it's right about at 1.5, 3.5. And now I have solved for x. So that's the point of intersection equals the solution. All right, B. Y equals negative 0.5x and y equals 6.5x plus 3. So first I'm going to do the slope equals negative 0.5, and then the y-intercept, it's not there, which means it's 0, since it's not there. For this one, the slope is 6.5, and the y-intercept is 3. So I'm going to draw my graph. Always draw the y-intercept first, and then use the slope to tell you where to go. So, if for my first one, my y-intercept is 0, start at the origin, go down a half over 1, down a half over 1, down a half over 1, down a half over 1. Draw a line through those points. And then my next one, my y-intercept is 3, 1, 2, 3. And then I'm going to go up 6.5 over 1. So 1, 2, 3, 4, 5, 6.5 over 1. Way up here. And then draw a line through that. And my solution is about negative 1/2, 1/2. All right, C. 3x minus 4y equals negative 12, and 2x minus 3y equals 6. So for this one, it's going to be easier to solve this using the x and y intercepts, to graph it using the x and y intercepts, than to use y equals mx plus b form, just because of the form that it's given to us in. So I'm going to find the x-intercept when y equals 0 for both of them. And then later I'm going to find the y-intercept, which is when x equals 0. So I'm going to do 3x minus 4 times 0, because y equals 0, equals negative 12. So I have 3x equals negative 12 divided by 3, x equals negative 4. So that point is negative 4, 0. My y-intercept happens when x equals 0. So 3 times 0 equals 3 times 0 minus 4y equals negative 12. So negative 4y equals negative 12. Y equals 3. So that point is 0, 3. For the next one, my x-intercept is when y equals 0. So 2x minus 3 times 0 equals 6. So 2x equals 6. Divide both sides by 2. X equals 3. That point is 3, 0. My y-intercept is when x equals 0. So 2 times 0 minus 3y equals 6. Negative 3y equals 6 divided by negative 3. Y equals negative 2. So that point is 0, negative 2. Now I'm going to plot those points on my graph. For this one, you need to make your graph very large, up by 10, so 10, 20, 30, 40, 50, 60, 70, 80, so on, and maybe up by 5s here, so 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60, negative 20, negative 40, 60, negative 80. Okay, so the points that I need to plot are negative 4, 0, and 0, 3. and 3, 0, and 0, negative 2. Okay, my graph is really not accurate. But if this is drawn accurately, the lines will intersect at negative 60, negative 41. All right, number 6. Faster Fitness has a monthly membership fee of $90. Members pay $5 to take an aerobics class. At Drop-In Fitness, there is no membership fee, but clients pay $10 per class. A, write a linear relation for the yearly cost in terms of the number of aerobics classes. So this should actually say write a relation for the monthly cost. So I did send you a note about that, so hopefully you caught that. So this is 16A. So I'm just going to write down what I know. Faster Fitness. $90 per month. And $5 per class. Drop-In Fitness is just $10 per class. So we need to write an equation for each one. So Faster Fitness would be $90 plus $5 per class, or 5x. And Drop-In Fitness would just be 0 because there's no membership fee, plus 10 times each class, or times x. So that's the cost. So we could say cost equals. All right, B, graph the equations on the same set of axes. So I'm just going to get the information from here. So if this is in y equals mx plus b form, then I could just switch those two around. So cost equals 5x plus 90. Now the slope is 5 and the y-intercept is 90. And for this one here, the slope is 10 and the y-intercept is 0. So now I'm going to graph that. So I'm going to just go up by 20s. $20, $40, $60, $80, $100, $120, $140, $160. And then on the y-axis, I'm just going to go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And this is the number of classes. This is the cost. All right. So my y-intercept was 90 and my slope was 5. So I'm going to plot 90. And then when I go up 5, I go over 1 with rise over run. So that means when I go up 10, I go over 2. So if I go up 10 to 100, I can go over 2, up 10, over 2, up 10, over 2, up 10, over 2, up 10, over 2. That line continues on there. And then for the other one, I start at 0 and I just go up 10 for each one. So that means I go up 20 for 2. So up 20 over 2, up 20 over 2, up 20 over 2, and so on. Continue that line. This one. That's really not straight. Okay, so my point of intersection happens at 18, 180. Oh, that's letter C for you. There's the answer, 18, 180. So what does this point of intersection mean in this case? This is D. What does that mean? So if the number of classes is 18 and the price is 180, for both gyms, that means both gyms will cost $180 for 18 classes. E says, how would you advise someone who's trying to choose between the two fitness clubs? So, if they plan to take less than 18 classes, then it's cheaper to do the drop-in. If you plan to take less than 18 classes, it's cheaper to choose drop-in fitness. But if you take more than 18, it's cheaper to choose faster fitness. Does that make sense? All right, that wraps it up. So let me know if you have any questions, and hopefully this helps for the test on Wednesday from 10 to 12. Thank you. Have a great day.